Hello all. We are starting with the fifth module, that is hashing technique. Okay. So why you are going for the hashing technique? So as you know, the sequential search, what happens when you go on accessing, we need to have a order of access n number. For example, if you are having n number of records, you need to have a n number of searches. Hence it is a time consuming. Next, similarly, if you go with a B tree, it improves the approach. But whatever the access we want, just in only one access we want to have information, hence we go for the hashing technique. So hence static hashing technique can be achieved only if the file size is not increased. Next we will see with the hashing. What do you mean by hashing? For example, suppose if you want to store a record, and if you take a key element, then that key element will be generating a address location. So based on that location your information is stored. So hence hash function is task is to what? To generate the address for a key record. So for example, if xyz is your key element, so that xyz we are extracting a location value, address value. So in that address your record will be stored. So hence hashing is also the same as indexing, but it differs with the two ways. One is what? It is not compulsion that every key element is connection to the location, and second key is that if you are having a multiple keys, same keys, duplicate keys for multiple records, then both can be generated to the same address. Hence hashing is different from the indexing. Next, what happens when you are having two records you are storing? Both will be having a key element as xyz, then both will be generating the same address. That leads to a collision. So how we can handle the collision is, we cannot avoid the collision, but we can reduce the collision. One is what? We can spread out of the records, so that if records are stored in a extra space, so that spread out there is no collision. Second one is we are using the extra memory, so that so we can store the other addresses for storing the records which are generating the same addresses. And third one is, instead of storing one record at single address, we can store the multiple records. So that concept we are using as what? Buckets. So that is three ways we can reduce the collision. Next, the important thing is hashing algorithm. So hashing algorithm, it will be represented with the three steps. First step is what? We need to represent the key element in the numerical form. For example, xyz is your key element. xyz or abcd is your key element. If you take the abcd, then what you do? We take the ASCII value of each. A ASCII value, B ASCII value, C ASCII value, and D ASCII value. We represent its numerical form. And second step is what? Fold and add. Then what we do? We take the two values. For example, A, B ASCII values we take, CD ASCII values will take. We can combine both and we can add. Then whatever the values we got from AB combining and CD combining, those values we are adding, and whatever the result we are generating, so that result is divided by a prime number. Then whatever the remainder value you get, so that value we are using as what? Address location for the storing of the records. So this is the simple hashing algorithm. Next, so there are different ways we can distribute our records. One is that, for example, if you are having a six locations, and if you are having a six key elements, all will be stored at the same location, then we can have that. Then we can say that it is the worst thing. For example, if you are having a six records, six locations, so each six are unique and each will be having a unique location stores, then we can call it as what? Uniform distribution. And if all are stored in only one location, then it is called as worst distribution. And what happens if out of six, if only one or two will be stored on the same address, remaining all are stored on unique address, then we can say that it is a random distribution. Next, pure informed distribution is difficult, because sometimes multiple records can be stored pointing to the same locations. So then which are the different hashing methods we can have? So first one is what? Examine a key of a pattern. For example, based on that we can generate every key value is unique, then it is important. For example, student ID value is not same for everywhere, so that we cannot have a collision. Similarly, that is the one method. Second one is for the parts of the key. Again, what we do? We take the key values, ASCII value, and based on that we can generate address. That is one method. Next one is what? Dividing by it as a prime number. That is the one method. Then one more method is what we do. For example, we take the key value and we can take the square value of that. For example, if 40 is our key value, then we take the 40 square value, then whatever the result you generated, 4 is generated, 40 square we generated, in that the middle 20. For example, if you are 40 square value is what, 1600, then what happens, the middle digit is 60, so then we can take that as a your address location. And fifth method is radix transformation. For example, if you are having a key value, you can take the one method. For example, for the base 10, if you take the log value, what is the value generate, you convert to 1 mere base 8 method, so that logarithmic transformation will be takes place. So that conversion of one form to another form is called as what, radix transformation. So these are the different ways we can avoid the collision rate. We can have proper distribution of records. Next, how we can use, we are using prediction of the distribution record by the Poisson distribution method. So this is the formula for that. Suppose if you are having 100 records, how you can distribute. So what are things is, how many locations you are assigned with only one record, how many records address you are assigned with 0 records, how many records you are addressed with 1-2 records, how many records you are addressed with more than 2 records. So this is we are calculating that, and based on that we are calculating the package density, means number of available spaces and number of records we are storing, that defines our package distribution. Based on the Poisson distribution, we are calculating the number of records. For example, your P of x determines what, you are having Poisson function is what, P of x equal to r divided by n raised to x into e raised to minus r by n. R is nothing but what, the random address, n is nothing but number of records. So based on that value you are applying how many records you are having. So based on this you are calculating p of 0, p of 1, p of 2, p of 3, like this way the different values you are calculating. Okay, next, how we can resolve the collision. So one method is we are calling as what, progressive overflow. For example, if you given a key value, if it generated the hash value as 18, okay, and next key value if you take, again it generates the hash value as 18. So 18 is already filled, next it searches the next empty location after 18, and in that location it will be stored. So this is the progressive overflow. For example, if all the for example you are having 1 to 100 location, if 18th location onwards all the locations are filled, then what happens, it again comes back 100, again it comes back to 1, then it wrap around will takes place, then it will be storing in that record. So with this what happens, the search space time will be increased. Okay, so this is about the progressive over length, and hence the search length for the progressive overflow technique will be go on increase, because the records are stored away from the home addresses. Okay, and one more method is what, as already told, how you can reduce the collision is storing more than one record for access. That concept we are calling it as what, bucket. For example, in each address location you are storing one record, instead of one we can resort as 4, so you can store maximum of 4 records. Okay, so hence the bucket size will be increased. Then how we can come to know that the record has been deleted. So deleted slot we are calling it as what, free slots, and it can be used for storing other records. So how we can come to know that the record is deleted, wherever you are deleted we are inserting the symbol hash, it indicates that that space is deleted, so you can reuse it later. So using that we are calling it as what, tombstone. Okay, so with the deletion it helps for what, reorganization, and next we can use that space for storing other records, so wastage of space can be reduced. And we are having a different collision resolution techniques. There are 4 are there: double hashing, chain progressive overflow, next chaining with separate overflow array, scattered table. Double hashing, what happens, when you give the key element, when you divide by the pi number, it generates the address. Suppose that address is filled, again we are dividing that address by again a prime number, again the next address what you are generating, that location we are storing a record, hence it is called as double hashing. Until we generate the empty location, we go on dividing the key value by the prime number, hence the name is what, double hashing. Chain progressive overflow, what happens here, when you divide the key by a prime number, it generates the address space. If that address space is located, then we search the where the next address is stored, that location you are linking with the pointer, so hence its name is what, chain progressive overflow. Next one is what? Chaining with a separate overflow area. It is here what you are doing again, that area here you are not storing the record actual to the address location. Instead of that, we are taking the pointer and we are taking the other area, other buffer area or overflow area. So that area we are storing all the records located to the same location we are storing there. Hence the name is what? Chaining with the separate overflow area. And last one is what? Scattered tables. So here each point each location we are having a indexing maintained with the pointer value. So there you are storing your records which are stored generating to the same addresses. Okay, so these are the four important techniques we can use for a collision resolution technique. Pattern of record access. So here we are accessing our records based on the also pattern. If you are having the same pattern records, they all are stored on the same location, then we can access it it easily, and you are having a shortest length. Okay, so for the fifth module, it is the one chapter I will be dealing. So it is the most easiest chapter you can have. Thing is that we can have what is mean by hashing a definition. Next, what do you mean by collusion, which are the different hashing methods. Next, hashing algorithm, hashing function and distribution, and different hashing methods, and you are getting one problem based on this formula. And next is collision resolution by progressive overflow. Next, tombstone technique, that is buckets. And last one is the different hashing techniques. Okay, so these are the expected questions you can have, and the most easiest and scoring topics are that. If you have any doubts you can approach me. So we are winding up with all the 5 modules, and I'll be dealing with only 2 things now. One is B-tree problem, and next one more is that's Poisson distribution problem. So if these 2 problems you can expect in your examination, and remaining all is of theory, so that will be I'll be uploading in my next class. So if you have any doubts, and you can ping me. Okay, thank you.